Hello, in this video, we'll expand on where we left off in our last video. So we will be taking our summarized and filtered data and turning that into tables and charts that can be used in a report or could be used for any data visualization purposes. And so we will continue right away where we left off in the last video. We're going to be using the same sample data set and summarized and filtered data that we did previously. And so let's get to it. So now that we have some data created or some tables or more or less some data frames, putting them and looking at it in the code form on a report is not recommended always. It's not very, very attractive. And it also doesn't have certain things you might want in a report, such as you might not be happy with something being called species display name. You just want it to be called species. But if you remove species display name from your data, then other functions don't necessarily work with that data, because that is the standard of what it's defined as. So that's where we say, like, if you really want to change the name of something in a table, it's better to do it within the table itself. And I will show you guys how to make a very simple table and then how to use a little more advanced package that allows you to really delve deep into your data. And so there's going to be two table packages we use here. And of course, if I was to reference this here, sample collections, it would not give me this summary breakdown. And so I'm going to call this, species breakdown. And I have defined that. And the knitr function has a function known as cable, which creates a very simple table. And if I just was to put the data in the cable like that, it's going to form here. Now, in an actual, see, it's kind of dark here with the background of my R. My R studio is dark themed. This would look like a normal table. Obviously, it's quite long and there's a lot to it. So if you were to then, if we were to just knit this file right now and see what shows up from it. From an HTML viewpoint, you can see that this, not here, this table shows up in HTML and it's just formatted a bit more appealing. Of course, this is not as, there's a lot of things you can do to customize this, and you don't necessarily need to include this in this format. Like this can be appealing for smaller tables. It can be appealing for general breakdowns. So when you have a whole bunch of data, if you just wanted to look at this data, this is not particularly helpful to you. If you're trying to think of like, well, I want to see the what is the most we've ever had of a species, right? You could theoretically take this and then run a filter on it and select for the max value and then look at that. Or if you don't want to go do that, you can use another function to get a data table. And this, again, this only exists within HTML and within R, and that is using the DT package, data table package. And so now if I was to put species breakdown here, this forms a table that is a lot more interactive and a lot more useful for sort of understanding your data if you just really want to look at it and see what you've really kind of analyzed, what you've looked at, what you've created. So like here we can like, okay, well, the most we ever had was by week, 11 Pythians here. And so this is a very helpful visualization tool, and it's very helpful in deciding what you want to do with your projects, or just kind of looking at how things are. And this does show up in the HTML. So if we were to knit this will show up. And as well, a nice thing about this is that it doesn't have every single entry point shown. And there's a lot you can do with the cable function up here to get it to look more like this, but it's not going to be interactive the same way that this does. And both of these functions are more than just something that you just plug a data frame in. So for example, in both of these, if we do comma and you press tab, you should see a list of the parameters, and you can see there's many, many parameters. And so as mentioned before, maybe you don't want it to be surveillance year, you just want it to be year. So you would do create a vector with C to create this vector, and you can say year, by week, species. And similar, data tables has a similar thing here where column names, obviously it's not the same parameter. It's their own format. So let's do that here. And I'll just show you guys. Oops. Here, let's do that. Well, now year, by week, species shows up. Note that I did not name the last column, so it just showed up as nothing. So maybe I should do that. So, there we go. And as well, you can filter things using the search bar, which is really nice in here, because if you just don't, if you want to just look at it directly, you can sort of filter as you go. But this is just a very helpful tool. One thing that's nice, this, however, while being a helpful tool, does not render in Word documents or PDFs. It will render as a PNG or just an image, which is, again, like that's not necessarily what we would want always. So it depends on what you're doing, what your purposes are. I do think it is helpful to see this. So these are just how to create basic tables. And one thing to know is that there are so many different functions. You can add captions, you can align the table differently, you can add rows. We will have links at the bottom of this video that tell you about the cable and the cable extra packages, and so as well as the data table package and different things that you are able to do. For example, in data table, you can highlight certain columns or do a ton of different things that you aren't necessarily able to do in just moving around a data frame in R. And some people really prefer the HTML style R Markdown files for reports because it's interactive like that. And so these are just two very simple ways. And so now that we've created these tables, and of course, as I mentioned, there's many different things we can do here. So this is the caption. Right, let's see. Say down by week and year. And you'll see that this shows up here. However, there's many different ways you can align this so that it shows up at the bottom of the chart and etc. This is actually the title, it looks like more. And so there's a lot you can do with that. Now that we have this, and one thing to note is that these table objects are not saved as tables. This is the output. If you wanted to save this table specifically, you can actually store this in a variable. So like my table, my DT, and then you can later reference this if you wish, and you can reference this in other chunks, and it should show up because this is now a data table object. And then obviously once I ran that, if you see up here, it actually created a object in my environment. And one thing, at any point, if you do, as mentioned, the sample data in the package does not change, but if you do change the data in your own local environment and you're frustrated by it, or you're not happy with the change that was made or a mistake happened, you can clear your environment with this broom here. This deletes all these objects, and then you can go back and rerun everything. And sample collections remains the same across the package. So that should not become an issue. So going from here with the species breakdown, we might want to say, okay, so this is great and all. It's nice that we have a table that we can look at things, but what does it actually look like? Because it's nice to see this, but when you think about it, this would be one whole, if we're by week one, this should be like one whole section, right? Maybe like a column or something where we are adding up and showing the breakdown of each of these species that exist within that data. So sometimes things are better shown in visuals than in words or than in just tables. So if you want to take this a step further, I'm going to show you guys how to create a simple GG plot, and then from there, I'm going to show you guys how to make that plot interactive. So ggplot 2, it's a package, but it is extremely useful and very, very commonly, it's very popular in R. The ggplot function creates this ggplot object. And see here, initializes the ggplot object. And then from there, we can add things to that object to create a more advanced or sophisticated graph. And so ggplot has two really major points in the very beginning, and that is like what data is being used for the plot, and then how we want to map that data. And when I say map data, I mean, how are we going to pin the data on the actual plot? So what is actually going to be shown in the actual chart or graph? So first thing we would do is create a ggplot object. This is the first thing you do whenever creating any ggplot, anything. And data, I want to choose the species breakdown. And then I would say, okay, so here we have this mapping aesthetics. And this is the point where we tell it what goes where. And at this point, we haven't told R what kind of plot we are plotting. So it doesn't know what we are doing particularly. So if I was just to do this, x equals, say I do bi-week. Let's do x equals bi-week. And then maybe I want y to equal the total. And if I was to run this, put this in quotes, because it knows the data, we don't have, it references the data similar to the dplyr package. Since we are referencing the data, we don't need to put it in quotes. But if I was to run this, we get a blank graph. And we know that it's total is supposed to be here and bi-week is supposed to be here, but we haven't told ggplot what kind of graph we are making. And so as a result, it's just going to give you a blank slate. So we might actually want something on our graph. So how we're going to do that is we're going to add ggplot objects to this other ggplot objects. We're going to add a layer to it. And so say we wanted to just have it in points. Maybe we just want to see the dot points. We can do plus, and we would type geom. And as you can see, a bunch of things show up. And these are all part of ggplot. These are all things that you can add on to a ggplot itself. And so, and there's a ton of them. And so we recommend, if you are interested to looking into this, so like total GG point. Well, now if I was to plot it, some points show up, and it actually will show you, this is the bi-week and total. So for each of these, all right, obviously, why are there so many points? You might ask on for each one. This is because there are multiple species and multiple collections within each of these bi-weeks, right? So for this bi-week, we broke it down by species. So every single tarsalis, every single pipian, everything is represented by maybe like one of these dots. Of course, that's not helpful if you don't know what these dots mean. And how would you map that? Well, you can actually map colors too. So if I wanted to map that, I could do map species. Display name. And now every single species has been mapped, like color mapped. Again, though, this can get confusing. It may not, maybe this is not exactly what you want to look at. Maybe you just want to look at tarsalis. So of course, we always have the option to filter the data specifically. Like before you actually put the data into the ggplot, you can filter it. So if I did like species tar, I could do species breakdown, and then I would like to filter on species display display name, and then I would like to tell you helix tar. So let's look at that. So there. And so then if I was to run a plot on species tar and still include species color, we would just get the tarsalis incidence here. And again, because there can be multiple, in this case, there can be multiple for any one point in the total. Oh yes, that's something to note too. We still have multiple in this data. And I don't know if anybody has thought about this so far, but it's good to note that this shows bi-week and we're looking at total, and we're really looking at the total for all the bi-weeks. We're not looking at any particular year. So for each of these bi-weeks, we're actually seeing the years that are present in the data. So if this is tarsalis for maybe 2016, and this is tarsalis maybe 2017, and maybe this is 2019 right here. Again, that's something where it's like, well, actually, maybe we want to filter on year. You know, surveillance year. Let's say it's 2016. And so this makes more sense for each bi-week. It shows, you know, for each point that exists for this. Now, maybe a scatter plot is not what you're looking for. Maybe that's not useful to you. Maybe you want to add a line to this scatter plot. Well, you can do that in ggplot. You can add a geom line like that. And then this will kind of draw a kind of a crude connected line in this case. And you can do a lot of different things to modify this, change the thickness. There's every imaginable way to modify this graph. I'm going to show you guys though, not just say you want to do this and you want to look at it for all the years in the data. So in that case, you want to still keep surveillance year in your ggplot, but you don't want to have multiple points for one bi-week because you're trying to compare the years. You can take it a step further and you can actually wrap your data along a specific, another factor. So just as how adding color gives a new level to the data, you can actually also add multiple smaller charts that break it up by surveillance year. And we will do that in a second. So if we were to go back, use this species breakdown, which is not filtered, that has, you'll see this is very chaotic. This is not very chaotic and it's very hard to interpret. It really makes no sense. So maybe in this case, if we wanted to then look at it on a by surveillance year, we could use this is another ggplot faucet wrap function. Then you put this little squiggly, and then you can wrap this, or more so, I would say this is splitting it up once more into surveillance year. And now we have these little plots that show everything. So again, though, this might be something where it's like, well, these are kind of small. Maybe you don't want all the species shown. Maybe you just want to look at pipiens and tarsalis. So you can do that if you were to do it species tarsalis here and then just not filter on year at all. Sorry, it's off. Sorry, we were in the filter on year and all species display name. So as previously mentioned, we can do in. We want to create this into a vector. So we're telling that there's multiple values. We have a sort of a list of values, and we can do. So we have just broken it down in that way, but it contains information for all the years and bi-weeks for pipiens and tarsalis. And so then we take this tar pip here, put it in here, then we look at it. Now it's a little more manageable to look at, as it doesn't have a million species in it, and we can kind of look at some of the peaks. And of course, this is not showing abundance. This is just showing the total number collected, which is not indicative of abundance because there could have been multiple traps or multiple trap nights run or different things that come into play when it comes to analyzing data. But as far as like visualization, this is giving the total number that was collected. So again, like I would not use this as a decision making. This is more for as like an exercise. We will show you guys in future videos how to get abundance and how to get infection rate and other things that are more useful for interpreting your data. Because like, once again, as mentioned, this being, this being right here is very large value could mean something, but there also could have been 20 traps run that night or run for this week for 10 days. And that's why there's that many Pythians in that case, or maybe they all ran it at one site. So there's a lot of different things you can break it down by. And something that might be useful to people is that you can actually pipe data into a ggplot. So if you really wanted to, like this portion right here, if we were to get rid of this data portion and then take this and then put it in front of here and then pipe it into the ggplot. So this is like takes it a step further that we can take the data we have, we can filter it, and then we can put it into a plot. You'll get the same thing because essentially it's taking this data, filter it, so it's taking that data frame, and then it's adding that into the ggplot. And ggplot knows that this is taking up the data component, and then the aesthetics are assigned accordingly. And so here we are with this, which maybe you don't want a bar. You can also do a bar plot, for example. So if we were to take this out, back to this, line plots aren't necessarily great in this case. We might want to keep the faucet wrap for surveillance here, but we might want to do geom bar. In this case, stat is here. The statistic is important. If for any of these, if you were to go into your console and do question mark and look at the actual function, you see that stat being count is the default. We want it to be identity. It can be a little confusing when it gets down to like what that means. But when I say I want it to be the identity, like any line plot, the stat is the identity. That means that what we're plotting, what we're telling it to map to is what it's mapping to directly. It's not trying to summarize things for us. It's not trying to do a function in the plot, because there are ways that you can put data into a bar plot and it will add it all for you into the specific categories that you want. In this case, we don't want to do that. We'll do geom bar, and we have to tell it, because we have X and Y, because identity uses X and Y, we have to do stat equals identity. Then if we run this, we have a little bit different looking thing here. And this, as you can see, is actually the total. And the reason why it looks weird is because we told it to color the line. And so you can actually change color here to fill if you prefer a different look. So that's, again, like this is showing us, this is the total number that was collected. And then this here is the portion that is Versalis, and this is the portion that's Pythians. And from there, maybe we want to add more to this plot. Maybe you don't like this being, you want this to be changed, you want this to be a different increment, or maybe you want the portion of the bottom of this chart, like this, the x-axis, to not just be in increments of 10, but in increments of 5 or 1, so it's a little easier to read. You can all do that. Those are all things that are possible in ggplot. Those are all things that you can even hide, that you can change the name of this. I'll show you guys really quickly how to label your graph, and that is using the labs part of ggplot, which is probably the most convenient one to use because it allows you to assign a title. So I could say Pythians tar salis comparison. And so that will change the title. We can say anything. So one thing to note is that title here is going to directly relate, things in title are going to relate to the things that we have mapped up here. So if I was to say X here, I want this to be capital bi-week. This is going to rename this variable, this portion right here is telling it essentially rename this to bi-week, but in the data, it still stays as what it is. And the same thing with Y. So we can do total, and then we can even define our fill here. So we said that this was fill. So if we were to put fill, and then set that equal to species, and run that, you can see we just changed a lot going on with, the aesthetics of this. And there's tons of different ways you can organize this. You don't have to do this faucet wrap breakdown, for example, if you didn't want to. You can, there are ways to have it on multiple sort of dimensions, but faucet wrap is a very nice way for just looking at general comparisons and just looking at things. And so from here, now we have this, and I misspelled first, I'll say that. Well, there's lots of different ways to organize this data and then look at it deeper. And so like for one thing we might want to do here, right, is perhaps just take this. I will show you guys how to make this interactive and make this a little more, I will simplify this plot really quickly by filtering on surveillance year here. And I would just want 2 years. I just want 2016 and 2017 for this data. And I'm going to, as I do this, here. And of course, I could have fed this into a ggplot that sort of way, but because I want to create a new, but wanted to have an actual new chunk, I decided not to do that. There's a lot of different ways you can do things, of course. And so now if I was to take this here and then change that to the new data that we made, it's going to be a little less complicated because there's only 2 plots. Obviously, there's a difference looking here. And so this is nice for comparisons, but say you're like, well, this is great, but I would like to know actually what this value is without looking at the data. It's nice to see it visualized, but what is this? This is obviously, this is over 2000, but what is the actual, what does this represent? And so you can actually make these plots interactive using the plotly library that we loaded earlier, and that's using a function called ggplotly, which is a very simple, it's a very simple function that you just take a ggplot object and put it into ggplotly, and it will render it as a HTML object. I'll say my graph, and then if I was to do ggplotly, my graph, it will render this graph. And this is something that can be rendered similar to the data tables, the DT data tables. It can be rendered inside of an HTML. And so if I was to knit this would show up in that HTML and it would be interactive. And so now that we've done this, if I was to scroll over something, I can see, oh, by week 15, total 829. And then I can, even from there, do a lot of things, like you could take out a certain portion of it, or you can zoom on specific sections in this plot, or you can look particularly at what's going on for each one point in the graph. You don't have to have it with 2 graphs. You could just have it with 1 graph if we really wanted to. We could just, instead of it being, if you just want to do it for 1 year, for example, it might be more useful in that case. Other things you can do is that you can save these as a PNG. You can select over them. You can scale it, zoom. You can download this plot, and all that is here will stay. You can even change the tags here. It says by week, it's lowercase. Maybe you want it to be uppercase. You change that if you really wanted to. There's a ton of customizable things. Pretty much anything that you want to do, you probably can do it with ggplot. It's not always going to be the right way, but there's a ton that is available, and we will have some more resources on this in the future. And in our future videos, we will be using VectorSurv functions to get things like abundance and infection rate, and then we'll be plotting and comparing those. And so a lot of this sort of basics that we've gone over, and even some of this more, it seems very complex when you look at it, but when you really break it down into what it's doing, it's not that crazy. And a lot of the code can be reused or resituated. And so this is just a simple introduction. And of course, there are multiple things you can add to this if we really wanted to. But that's pretty much it for this training. So for those of you who may have knitted an R Markdown file or seen the ones that we've knitted in these videos, you'll notice that there's a lot of code and there's a lot of things that can exist that are sort of not report ready in a way. Like it's sometimes good to see what has been done, but also it can be quite kind of convoluted. And sometimes the people who you are presenting to are not interested in the technical part of it. They just want to see the plots or the graphs. And so in the next video, we will go into how to clean up an R Markdown file to make it more report friendly and making it into something that you can share with an agency board or someone who's not knowledgeable about the code, but does know a lot about interpreting plots, for example, and other ways like that. And so we look forward to seeing you guys next time.